Okay. One of them is temperature T1, the other one is at temperature T2. Heat, we all know, would flow from the higher temperature to a lower temperature. Why not from a lower temperature to a higher temperature? Huh? So can we prove that mathematically? Yes? Yes? Everybody can. Yes, no. What is the total entropy? So let's say we have this box. I have T1, I have T2. It's all insulated box, okay. So there's no loss of heat. So what's the change in entropy? Huh? dq1 by T1 plus dq2 by T2, and whatever the heat has been given by 1 would be taken up by 2, or the other way around. So dq1 would be negative of dq2. So if I could write that, dq1 into T2 minus T1 by T1 T2. Yes? Now, you want that ds should be greater than 0. And when would that be true? If T2 is larger than T1, then dq1 should be positive, which means heat should flow from 2 to 1. If T1 was larger, then heat would flow from 1 to 2. Only then in those cases your change in entropy would be a positive number. Let's take a look at another one, another of these examples. We have another 3-4 minutes, okay. Think of a box now. We studied the Joule-Thomson, yeah? Think of this insulated box. No, not Joule-Thomson, the Joule expansion, okay. And I have a gas over here and vacuum over here. And the volume is V here, fine. So let's say we just have 1 mole of gas at volume V, temperature T, and it goes to, it's still, the number of moles don't change. Volume becomes 2V, temperature still remains T, it's free expansion, isothermal, no? It's adiabatic, sorry, but it's free expansion. That's a very interesting thing. An adiabatic free expansion and an isothermal free expansion is exactly identical. Huh? So, I open this wall in between, and what would happen? The gas would cover the entire. Why? Why doesn't the gas as well just sit there peacefully? Think in terms of entropy again. And if I have to think in terms of entropy, this is an irreversible process, an expansion. So, let me try to trace the path back. Let me try to compress it from 2V to V. Can't do it against vacuum, nothing, yeah? I can't start that way with P is equal to 0 and then do it. That's impossible, yeah? So I have to think of some method which could do it reversibly. Let's try isothermal, because if you remember what I have done, essentially, let's say these are the 2 points and this is my isotherm. So what I have done in case of this expansion is that I have taken from point A to point B, not along this line, but that's how it has expanded. And still on the isotherm. Point B is on the isotherm, yeah. So I could as well do a reversible isothermal compression. If I do that, you can as well calculate what the heat is. All I need to do is ds minus dW reversible by T. dW is again PdV. The limits would be from 2V to V, and all that gives me is delta S is equal to R ln2, which is greater than 0. Delta S of expansion. So delta S of compression would be negative of this. Okay. No, I'm compressing. No, so that's why I wrote delta S of expansion. I said delta S of compression would be negative. Okay. I skipped a few steps over there because I know what the answer is. Okay, good. So we'll meet next week with some more interesting examples and